Hi, my name is Cameron Fife, and I am doing my presentation on cholera. I chose this topic mainly because it's an issue that many third world countries are still suffering to this day. Um, Cholera is based off the bacteria Vibrio acariae. It is a severe diarrheal infection caused by this bacteria, which can be contracted by eating or drinking contaminated food or water, usually fecal contaminated. And the origin of this bacteria, cholerae, is from the word cholera. Vibrio is two quivers. And as you can see on this image on the right, you can see she's drinking this clean water. This is not what it is. This is what they're actually drinking. This disgusting, contaminated, look at all this junk is in their water. And she's grabbing this bucket and able to drink it. Like you can see all this dirty fruits, all this trash and stuff that she's consuming to her body, which this bacteria will attach to her and cause her this disease. So, how is this able to survive? How is this bacteria able to have such a crazy effect? Because it attaches it to humans as well as animals living in your waters to serve as a reservoir for this disease. This is how it's able to survive. It attaches to the birds and herbivores near fresh waters, in lakes, well as algae, copepods, etc., and have been reported to carry this bacteria. And as you see in this diagram, it starts at the aquatic reservoirs, then the humans or the birds or any other animal oral ingests it, the contaminated water and food, and then this bacteria attaches itself to the small intestine, and the body signals it, and the toxins cause the body to secrete water in the rapid loss of fluids of diarrhea. So the epidemiology, cholera swept over the world during the 19th centuries with its origins in the India's Ganges Delta. For more than 6 decades, the disease has been this prominent cause of the epidemic diarrhea in Asia, Africa, and Latin America, with a higher prevalence in tropical and subtropical countries. This is because those countries don't have a wash system like many countries like the U.S. has and like Russia, etc. And each year, several million cases of cholera are reported, with children aged 2 to 9 and women of childbearing age being the most common people to be affected in endemic areas. So, you can see on this image on the left is Africa. You can see Nigeria, Ethiopia, Kenya, Zimbabwe, Zimbabwe, etc. Because Asia has reported more cholera cases and deaths than any other region in the 21st century. 60% of the reported cases are from Africa. And you can see this diagram here, all the blue highlighted. It's dark blue, mainly in Africa, because those places are mainly highlighted. Mainly are the people to be contaminated with this bacteria. You can see on this diagram on the left, you can see Latin America, Africa, and Asia are all bright green. I can't look at colors. Bright orange. And this is from reported cholera cases from 2010, 2015. And it's estimated every year that there is 1.3 to 4.0 million cases of cholera, 21,000 to 143,000 deaths worldwide due to this infection. And you can see in this diagram, my head kind of cuts it off. Asia in 2017, it's that light blue, had the biggest growth spurt in 2017, but all this like navy blue, kind of light baby blue, not baby blue, like the regular color blue is Africa, which is the main ones throughout since 1989 to 2016. So, what is the makeup of this bacteria? The bacteria is a gram-negative non-spore forming oxidase positive curved rod. It possesses a singular polar flagellum and is exceedingly motile. That bacterium is a facilitative anaerobe that measures 1.3 m by 0.5 to 0.8 m and belongs to the Viroinase family. In this image here, it can show you the structure of the bacteria, the cytoplasm, the plasmid, the capsid, the cell wall, plasma membrane, the ribosomes, my head kind of cuts it off, and the flagellum is that long green stem. This is just what it looks like under a microscope. You can see how big this bacteria is and how long the flagellum is to able to move. So you can see here, it breaks down how it becomes a variant. Serogroups based on the structure of the cell membrane, the liposaccharide, O-antigen of the Vibrio cholerae strains is divided into two biotypes, classical and L-Tor, which are the primary responsible for the cholera outbreak. Each biotype has a distinctive serotype, Inaba, Adagua, and rarely Hikojima. And you can see on the left image, it divides it to serogroups and serotypes. You can see the O1 goes to Agua and Itaba. Then it goes O1, 139. Then it goes to the non-1, which is that did not cause cholera, and the left is that causes cholera. On the right is the biotypes, classical and L-Toro, which is the prototype and variant, and how it divides to the four. So, Vibrio cholerae O1 is a distinction by the two major variant factors, CT and TCP, which is cholera toxin and toxin co-regulated pilus. The cholera toxin is an encode by the CTX prophages, CTXA and CTXB genes, and it causes diarrheal illness with significant water and electrolyte loss, which is the diarrhea, as I said. The TCP is essential for the bacteria to colonize, which it makes it to multiply. And you can see on the image on the left, you can see how the TCP is all these different things, and the little lines will show how it multiplies, and then it goes to CT, etc. And that kind of chart kind of confuses you. Here's an easier one to see. You can see from 0 to 1 to 0 to 1 hour, you can see the bacteria enters the body and it signals it. Then you get to 2 to 3 hours where the TCP, you can see the flagellum is forming. When that flagellum forms, you know what it causes? It causes motile, multiplication, colonizing. That's why CT, the toxin, when it hits 4 hours, that's when it gets toxic. And you see it multiplied and colonized to different things, all tangled together. And then the water and electrolytes exit the body, which is diarrhea. We get to symptoms. In this diagram here, you can see it breaks it down. The three main common symptoms is watery diarrhea, nausea and vomiting, and dehydration. Then when it gets to severe symptoms, it goes to muscle cramps, rapid heart rate, low blood pressure, persistent vomiting. The majority of those who develop symptoms have mild or moderate symptoms, whereas a small percentage have an acute watery diarrhea and severe dehydration. If left untreated, it can result to death. Before symptoms occur, the bacteria colonizes the small intestine for 12 to 72 hours, which is the incubation stage. The bacteria are present in these feces for 1 to 10 days after infection and are shed back into the environment, potentially infecting other individuals. And here you can see the incubation stage, like more pretty and colorful. So day 1, you can see it's not a lot. Boom! Day 7, you can see, multiplies, colonize, it becomes in little circles that it wants to get. Day 27, look at that big bacteria together. Look at it. being beautiful as it is. And in day 45, you can see it separates into two, etc. How to diagnose. So, culture of the stool specimen or a rectal swab. That's how they're able to see what it is. The TCBS, I wish I could say what the agar is, but I'm calling it TCBS, is suitable for isolation and identification, and that's what the image is on the left. It produces these yellow colonies that are readily visible on dark green backgrounds. You can detect it, as you saw in the two images before this of the microscope. It's detected by a dark field or a phase convex microscope. And you can see on this image 11, you can actually see how it grows, how it turns the agar yellow. And here's a couple images of the water that they're drinking. You can see this little boy, you can see he's getting water out of this dirty trash. You can see dirty water, and it all can be like it's this dirty, poopy color. It's so sad. Here, this little town, you can see the water, and he's like all in the bottom. You can see all that trash that he's gonna consume in their water. Haiti, with their water, you can see with that little cliff, you can see all of that trash. It's so sad. So, how do we prevent it? Do not eat or don't eat raw or undercooked shellfish such as oysters because they live in water. Wash hands often with soap and safe water. Use Listerines, bury your poop. Do not poop in anybody's water. Peel fruit and vegetables. And you saw one of the first images, you can see there's fruit in their water. It's very important to peel your fruit and vegetables. You never know. Clean up safely in the kitchen in places where your family bathes and wash clothes. Then, treatment. Cholera, luckily, is easily treatable disease. As because if you guys know how your body works, you know diarrhea takes a lot of electrolytes and water out of your system, and especially since this disease accumulates so much water for it to become so much water diarrhea that you're losing a lot of water. So they produce this treatment, which is an oral rehydration solution. It's prepared a mixture of sugar and salts that is mixed with 1 liter of water and drunk in large volumes to treat patients. And it's the primary treatment for this because dehydration is the key of cholera, which is why a lot of people in these third world countries aren't able to heal as there should be because they're drinking this water, which is making them sick, and they can't keep drinking the water if it's making them sick. So they produce this mixture, which will keep them rehydrated. In severe situations, intravenous fluid replacement is often required. Antibiotics help to lessen the illness duration and intensity. And you can see on this image on the left or the right, you can see they are pouring this liquid in their mouth. And you're wondering, what is this liquid? This liquid is the vaccine for cholera. It is the Dukoral. It's an oral interactive transmitted vaccine. I will say in a second. In this image, like I said, Dukoral has been approved by the WHO, the World Health Organization, for the UN supply for people who suffer with this disease. Vaxichlor is a single-dose live oral cholera vaccine licensed by the FDA for persons aged 18 to 64 who are traveling to an area where toxigenic viral cholera is active. No cholera vaccine is 100% effective, just as the flu shot, same thing, not 100% effective. How can we control this bacteria? Economic development and universal access to safe drinking water and proper sanitation are the long-term solutions to control cholera. These Precautions protect against chlamydia, both epidemic and endemic, as well as waterborne infections, and chlamydia is intimately linked to unfavorable living situations, as you saw in the many images I have shown. And here's all the references I used. Thank you so much for listening to this presentation, and I hope you learned more about the bacteria.